Hello dear friends, and welcome once more to this video in our YouTube channel. In this video friends, we shall be looking at a comprehensive study of the quotient rule of differentiation. Guys, we shall be looking at this concept with the help of well solved and explained examples. So friends, make sure you watch the entire video so that you're going to have a complete understanding on the concept. So friends, if you're new to this channel, don't forget to subscribe to the channel, because by subscribing to the channel you're going to have all latest updates, provided you turn on your bell icon. Guys, when you subscribe to the channel, make sure you turn on the bell icon so that you're going to have all latest updates about the contents we produce here. Guys, the contents we produce here are contents that are based on biology, chemistry, physics, mathematics, further mathematics, computer science, and so on and so forth. Guys, so just simply press the subscribe button and turn on your bell icon to get notified. Great. So friends, as you can see, the rule simply states that if we have two functions such as y equal to u over v, keep in mind that u and v are functions of x. Then guys, to differentiate y, that is dy by dx, is simply going to be, we are going to keep the bottom constant, differentiate the top, that is du by dx, minus keep the top constant, differentiate the bottom, we are going to have dv by dx, all that on the bottom squared. Guys, let's sing it as a song. If we have two functions such as u and v, which are functions of x, then guys, dy by dx is equal to, now friends, let's sing, bottom constant differentiate the top, minus top constant differentiate the bottom, all that on bottom squared. Great. I think we sung the song right. Great guys. So friends, let's look on now to let's just go ahead now to look at our soft examples. Guys, I shall explain very well, guys. I shall explain very well such that you're going to understand the entire concept, because it's super important. Most students always get mixed up with this particular law of differentiation. So guys, let's look at soft examples. Great friends, let's look at those examples. I think we are going to have about 6 examples, guys. The first one we have y equal to cosec x. Second one we have y equal to tan x. The third one we have y equal to x over tangent of x squared. Then the equation 4, guys, we have y equal to x squared plus 1 over sine x. Equation 5, we have y equals to the natural log of cosine of x over x squared. Then the sixth question, guys, we have y equal to cosec x over x cubed plus 6. So friends, I'm going to explain the whole concept, okay? I'm going to explain qualitatively as we will be solving this example. So guys, let's look at the first. Let's have our solution. Let's look at the first. We have y equal to cosec x. Friends, from trigonometry, we know that cosec x is the same like what, guys? 1 over sine x, right? Great. So we have 1 over sine x. Now we can see the quotients of two functions, right? Great. So friends, in this case, we know that our dy by dx now simply becomes, like I said, guys, we are going to keep the bottom constant, that is bottom constant differentiating the top. Differentiating 1, guys, 1 is a constant, right? So it gives us 0. The derivative of a constant, guys, you all know to be 0. That's why we have 0 here. That is the bottom constant differentiate the top, which is 0. Differentiate 1 gives us 0, minus top constant, the top is 1, we have minus top constant, differentiating the bottom, differentiating sine x, guys, gives us cosine of x. That's what we have here, all over the bottom squared. The bottom is sine x, so everything squared gives us sine squared x squared. So friends, if we simplify so well, we are therefore going to have our dy by dx to be the same like anything times 0 is simply 0. So we have negative cosine of x over sine square x, the same like what, guys? Sine x times sine x, right? What is cos x over sine x? Great. That is what, guys? Cot x, right? Good. Then we have 1 over sine x. So we are therefore going to have our dy by dx to be the same like negative cosecant x times cot x. Great. That's it, guys. That's the derivative. But friends, at this point in time, you are done differentiating, okay? Since the equation did not say you should leave your answer in a particular form, anyway, any form in which you leave your answer is accepted. Great. That's it, friends. So friends, I hope you understood. If you didn't understand, guys, keep your worries in the comment section down below. If you understood, make sure you comment to let me know if you understood. That is going to help me, guys. All right, let's look at the second question, guys. We have y equals to tan x. Friends, what is tan x? Sine x over cos x, right? Great, so we have y to be sine x over cos x. Similarly, guys, dy by dx simply gives us, now guys, bottom constant. What's the bottom? Cos x. We keep it constant. Differentiating the top, which is differentiate sine x, guys, gives us cos x minus the top. Keep the top constant. The top is what? Sine x, right? Differentiating the bottom, differentiate cos x, guys, gives us negative sine x. All that on what? Bottom square. The bottom is cos x, so we square it. Friends, what is minus sine x times minus sine x? Gives us positive sine squared x, right? Good. So we have cos x times cos x, which gives us cos square x. So we are therefore going to have our dy by dx will seem like we have cos squared x plus sine squared x all over cos squared x. Good. But friends, what is cos squared x plus sine squared x according to trigonometry, guys? Great. It is 1, right? Good. What then is 1 over cos squared x? We have sec squared x. So our answer becomes sec squared x. Great. Friends, this is the derivative of tan x. In fact, guys, you can simply state it out unless the question asks to prove or to show. That's why you have to pass through all this procedure. Just like you know that the derivative of sine x is cos x, the derivative of cos x is negative sine x, you should also know that the derivative of tangent of x is what? Sec squared x. Great. It's going to help you so well in integrations particularly. All right, let's look at question 3. Question 3 says y equal to x over tan x. All right, guys, let's do it. Dy by dx simply gives us the bottom constant is what? Our bottom constant is what? Tan x, right? Differentiating x dx gives us what? 1. Good. Minus top constant, we keep the top constant. The top is what? X. Multiplied by the derivative of tan x. What's the derivative of tan x, guys? We did it initially, right? It was what? Sec squared x. So that's what we have it there. All that over the bottom square. The bottom is tan x. So we square that, you have tan squared x. Guys, if you simplify just a bit, though you are not expected to simplify, by just clearing off that one, we are going to have our answer to be tan x minus x sec squared x over tan squared x squared. That's it, guys. That's it. Let's look at question 5, guys. I'm sorry I won't do question 4, okay? You can do it in a similar manner like this, okay? But make sure you do it and put your answer in the comment section on below. Let me see if your answer is correct, guys. If it's correct, congrats. If your answer is not correct, I'm going to show you how to answer it. Great. All right, question 5. We have y equals to that. So friends, dy by dx simply gives us, as you all know, guys, we have the bottom constant. The bottom is x squared, so we keep it constant. The derivative of natural log of cos x, guys, let's get that. Now, guys, do you see that the top is a natural log function? And I made a video on how to differentiate the natural log function, right? I'm sure you saw it already. So we are going to just have the input as if in the denominator, then the derivative of the input, the derivative of cos x is what, guys? Negative sine x. That's why we have it at the top. Great. Minus the top constant. The top is natural log of cos x. Keep it constant. Then differentiating the bottom gives us 2x, because differentiating x squared gives us 2x. All that over the bottom square. The bottom is what, guys? Is x squared. So squaring that, we have x squared, all that squared. But friends, we know that there's an x to the power 4, right? So one of the x can cancel here, and cancel here. So at the end result, we are going to have dy by dx to be the same like we have x squared into we have sine x over cosine of x. This we have 2x. Good. Natural log of that. Great. So that's what we have, guys. I've simply repeated all of this. Okay, I've repeated all of this. So friends, the final answer dy by dx gives us negative. What is sine x on cos x, guys? Is tangent of x, right? So we have negative x, because the 1x will cancel here, cancel the bottom, then cancel. So here we're going to have but x to the power 3, then minus 2 natural log of cos x over x cubed. Great. That's it, guys. Let's look at question 6. Great. That's question 6. We have y equal to cosec x over x cubed plus 6. Great. All right, friends, let's go ahead. Dy by dx gives us, now friends, let's be careful. Bottom constant, the bottom is what? X cubed plus 6, right? Differentiate the top, differentiating cosec x, guys, we did that earlier, right? This is cosec x. That was the first question. And we had our answer to be what, guys? To be negative cosec x times the cotangent of xy. So we have it here. Minus the top. The top is cosec x, so we have it here. Then times the derivative of the bottom. The derivative of x cubed is 3x squared. Derivative of 6 is a constant. We have 0. So we just have 3x squared over the bottom squared. The bottom is x cubed plus 6. We square that. Simplifying, guys, we are therefore going to have our answer to be negative cosec x. That is where we factor out our negative cosec x. We factor out everything. Right? We have it here and we have it here. We are going into, we have x cubed plus 3. X cubed plus 6, sorry. Then cot x plus 3x squared all over x cubed plus 6 squared. So friends, that's it for the video. That's it. I hope you found it useful, guys. If you found it useful, please give it a thumbs up. And place your comments, place your worries in the comment section down below. And at least tell me if the video was good, if you learned something, guys. And if you've not subscribed to the channel at this point in time, guys, make sure you hit that subscribe button. By that, you're going to have all latest updates about our content, guys, and turn on your bell icon so that each time I post any new video, guys, you're going to be the first person to get notified. Thank you very much, and have a blessed day.